y is equal to negative tangent of x. Anything else? Any other graphs? We're good? Alright. Let's do y is equal to cosecant of x over 2. Okay, what you want to do is you want to rewrite this as a cosecant of 1/2 x. Okay, it's the same thing as x over 2. This is going to tell us, this is the frequency right here, so that will tell us what the period is. To find the period, and that's what you need to figure out, you're going to take 2 pi, we're going to do it in radians, and then we're going to divide by 1 over 2, which will give us 4 pi. Okay, so period is 4 pi. So we're going to start at 0, and we're going to go to 4 pi. Any questions? That's one full period. We're going to start cutting everything in half. That's 2 pi. That's pi. And that's 3 pi. Okay. Now, cosecant is related to sine. So, if you remember, cosecant of x is the same thing as 1 over sine of x. So we're going to use sine of x to help us graph cosecant. You don't have to, if you just memorize cosecant graph, you don't have to do that. So I do know one thing about sine graph. So I'm going to, that's easy to graph. And I know the highest value sine is going to be 1, and the lowest value is going to be -1. Okay. So we're going to make sure we're going to put those points on my y-axis there. Okay. Okay, that's my y-axis, and that's my x-axis. Now, sine starts here at 0, 0. And it starts going up to 1. Comes back down to 0. Goes all the way down to -1. Comes back down to, comes back up to 0. So this is your sine curve. And I'm doing it in a dotted line because I really want to graph a cosecant graph. Okay. Now, since cosecant is 1 over sine, and sine is in the bottom of a fraction, every place sine is 0, I have a problem. So sine is 0 here, here, and here, and I have a problem. The problem is I can't have that. So that's where I'm going to get my vertical asymptotes. We'll get vertical asymptote here, and vertical asymptote there, and vertical asymptote there. Alright. Cosecant is really reciprocal of sine. Reciprocal means to flip it. Okay, so I'm going to start here. I'm going to flip this curve up. So it looks like a parabola, but not quite. Okay, and this is going up here, so it's going to go down now. And then you're done. Alright? Alright, y is equal to negative tangent of x. Well, let me ask you this question. If you have y is equal to x squared, we know what that looks like. That's a parabola that opens up. Looks like that. But what about y is equal to negative x squared? What will that do to that parabola? It opens down. It's the same thing with the tangent. So, original tangent curve, you should know that by now. Okay, it looks like this. And you're going to have a vertical asymptote at negative pi over 2. And you're going to have a vertical asymptote at pi over 2. Okay, that's the original tangent curve. Well, what does a negative do to that? It makes this part here flip up, so it's going to look like this. And the top comes down. And that is negative tangent of x. Okay. What's up, Brittany? How you doing today? Oh, got it right. Alright. You had a big old grin like you got caught with your hand in a cookie jar or something. Yes, sir and sir.
The negative tangent graph is the same as the cosine.
No, it is not. Okay? Alright. The question is this. excuse me, he asked a question, I'm going to answer his question. I know for you the world revolves around you, but my world does not revolve around you. Okay, here we go. Cotangent graph looks like this. Period still pi. This negative tangent, that's shifted over. Okay, it's a good question because a lot of you do not understand what cotangent, co in cotangent stands for, or co in cosine. So that's a good time to talk about it. What does co stands for means complementary. Complementary means how many degrees? When we say complementary angles, what are we really talking about? 90, right? You should know that from geometry. So, in radians, 90-degree shift is pi halves. Okay, so that means cosine graph and sine graph are exactly the same, except cosine graph is the same as sine graph, just shifted 90 degrees to the left. That's all it is. So if you take sine graph and move it 90 degrees left, you'll get cosine graph. Okay? So that's what cosecant means, and that's what cotangent means. Okay, that's what cosine means. Okay, it means we're going to shift the other graph 90 degrees to the left. Okay. Let's go to section 31. Oh, yes, David. Okay, we're still section 32, number 3. Number 3, you have y is equal to 5 cosine of 2x. First of all, you have to figure out what the period is. Period is, I want everything done in radians, please. Okay. Period is 2 pi divided by this number, which is called a frequency, which is 2. That is going to give you a pi. Okay, the period is pi. Now, while we're here, we might as well talk about what this thing, frequency, really means. Frequency means that a normal cosine curve, it takes 2 pi to finish, start to finish, 0 to 2 pi. If it says 2, that means it only takes a pi to finish that. So within 2 pi distance, okay, so what happens is within 2 pi distance, it's going to have 2 of those curves. So if this number was 4, within 2 pi distance, you're going to have 4 of those curves. So when you turn on your radio to a frequency 94.1, that means the radio wave that is coming in within 2 pi distance, there's 94.1 radio waves in there. Okay, so when you turn on your cell phone, you get a phone call. Okay, there's a wave that is coming in with the particular frequency that matches your cell phone, so therefore you can talk to people. Otherwise, you can talk to everybody else's friends. Okay, so each cell phone has its own unique frequency. So when you lose your cell phone, or when you get a new phone, they say, do you want to keep your same number? All they're doing is they're matching up the frequency that you already have. When they change a number, that means you're going to change the frequency on that cell phone. So they just take that chip, put it back in there, and then you're good to go. Okay? So that's all they do. That's why you get to keep your number. So that's frequency. So having said that, okay, let me show you how easy it is to graph this. You should know what cosine graph looks like. Here it is. Can you do that? That's what cosine looks like, right? Okay. Here you go. 5, negative 5. 0, pi. Cut it in half, pi over 2. Cut it in half, pi over 4. Cut it in half, middle there, 3 pi over 4. Done. So the only thing I've changed is the numbers on the x and the y axis. Okay. So the graph still looks the same. Okay, so everybody should know what cosine looks like. Everyone should know what sine looks like. Everyone should know what tangent looks like. Okay, everyone should know what cotangent looks like. Of course, secant and cosecant, you can use sine and cosine to flip it. Okay, yes, Brittany. Now, no, I'm gonna be checking for this, see if you have the right period. That's why I need those markings. So on the x and the y-axis, I need the markings, so that way I know you know what the period is. Okay, are we done with graphing? We'll get the harder ones on Monday. So how about section 31? Section 31. Okay. How about section 30? Converting degrees to radians, radians to degrees. Moving on. How about section 29? We're good? Alright, the last one is the unit circle. I'm not going to ask you to draw the whole unit circle, but I'm going to take the problems from section 28, okay, and say, hey, tell me what cosine of 150 degrees is. Tell me what tangent of pi halves is. Okay, you can't use your calculator. You will not be able to use a calculator this week on tomorrow's quiz. No calculator. So that way you won't give me those decimal answers. So how about section 28? Any questions? Everybody's got the unit circle down pat? Yeah? Wow. Gosh. Okay, David wants me to go back to section 30. Pick, David. Pick, David. 2 and 3. 270 degrees. Change it to radians. Multiply. Degrees go on the bottom so the degree signs can cancel. Pi goes on the top. Zeros cancel. Shh. David's trying to learn. Okay, we'll go to both 27, 9. How many times? 3 and 2. Wow, look at that. 270 degrees, same thing as 3 pi over 2. Alright. And number 3. You have 7 pi over 3. What do you think I'm going to put on the bottom so I can cancel out the pi's? Pi. Very good. Okay, that means 180 has to go on the top. Pi's cancel out. The radians are gone. How many times will 3 go into 180? What's that? 60. Okay, so what's 7 times 60? 420 degrees.